Question 1. The function f is defined by function f such that x is converted into 2x minus 3. A. Find the expressions for f square and f inverse. F square x is equal to f of fx. We substitute fx into the function f. We have 2 fx minus 3. Further substitute fx again. 2x minus 3 minus 3. Then we expand the bracket. 4x minus 6 minus 3. Simplify it. We have 4x minus 9. To find the inverse function of f, we let the inverse function of f equal to y. X equal to fy. Substitute y into the function f. We have 2y minus 3. Make y the subject. Y equal to x plus 3 over 2. Hence, inverse of f is equal to x plus 3 over 2. B. Show that f inverse square is equal to f square inverse. In order to show that they are equal, we have to do them separately. First, we need to find f inverse square. It means f inverse into f inverse. The function f inverse we already obtained in part A, which is x plus 3 over 2. Since our object is the inverse of f, we have inverse function of f plus 3 over 2. Substitute it again, we have x plus 3 over 2 plus 3 over 2. Simplify the function, x plus 3 plus 6 over 2 multiply with 1 over 2. Together, we have x plus 9 over 4. Then, we need to find f square inverse. The function f square, we also already obtained it in part A. To find the inverse of f square x, we let the inverse of f square x equal to z. X is equal to f square z. Substitute z into the f square, we get 4z minus 9. Make z our subject, we have z equal to x plus 9 over 4. Therefore, f square inverse of x is equal to x plus 9 over 4. Compare the answer that we obtained for f inverse square, which is x plus 9 over 4, and the answer for f square inverse, which is also x plus 9 over 4, we can conclude that they are equal. Question 2. Given the function f such that x is converted into 4x plus a and its inverse function of f such that x is converted into bx plus 5 over 4. Fx is 4x plus a And inverse function of f is equal to bx plus 5 over 4. A. Find the value of A and of B. Since we are given the function f and f inverse, we need to find the f inverse ourselves, and then we compare the answer with the given f inverse to obtain our A and B. Let the inverse function of f equal to y, x equal to f, y. Substitute y into the function f, we get 4y plus a. Then we make y our subject. We get y equal to x minus a over 4, which means inverse function of f is x minus a over 4. Compare the inverse function of f we obtain with the given f inverse. As comparison, b is equal to 1 and our negative a is 5, which means a equal to 5. Now we have the complete function for f and f inverse. B. Find the expression for f inverse of f. F inverse of fx. Substitute the fx into the f inverse. We get fx plus 5 over 4. Substitute again, 4x plus 5 plus 5 over 4. We get 4x plus 10 over 4. We can simplify the equation. We factorize it into 2 and bracket 2x plus 5 over 4. Cancel the 2 and the 4. And finally, we get 2x plus 5 over 2. Question 3. Given that the inverse function of f such that x is converted into 1 over k minus x, where x is not equal to k, and function g such that x is converted into 2 plus x. F inverse of x is equal to 1 over k minus x, and also gx equal to 2 plus x. A. Find the function f in terms of k. We are given the inverse function of f and we are asked to find the function f. Normally, when we want to find the inverse function, we let the inverse function of x equal to y. Then we make x into fy. Here, we are finding the function f, so we're going to do the opposite one. We let f of x equal to y, x equal to f inverse y. Substitute y into the f inverse, we get 1 over k minus y. In order to make y our subject, we multiply both sides with k minus y. Divide both sides with x. Then we separate out the y equal to k minus 1 over x. And therefore, we get our fx equal to k minus 1 over x. F of x equal to k minus 1 over x. B. Find the value k if f inverse of f k squared plus 2 is equal to g of 2 plus k squared. Before we can find the value k, we need to do the composite function separately. First, we find the value of f inverse of f k squared plus 2. This composite function looks a bit complicated, so I'm not going to find the general function for f inverse f, but I will find f of k squared plus 2 first and then substitute it into f inverse. F k squared plus 2 is equal to k minus 1 over k squared plus 2. Make it into a single fraction. We multiply the k with k squared plus 2. Then we will have the same denominator. Then we continue, substitute this value into the f inverse. We have f inverse of k cubed plus 2k minus 1 over k squared plus 2. So we get 1 over k minus k cubed plus 2k minus 1 over k squared plus 2. Simplify the fraction. We have 1 over k multiplied with k squared plus 2 minus k cubed plus 2k minus 1 over k squared plus 2. Continue over here. 1 over k cubed plus 2k minus k cubed minus 2k plus 1 over k squared plus 2, which is 1 over k cubed minus k cubed is gone, 2k minus 2k is gone, so we're left with 1 over k squared plus 2, which is k squared plus 2. Then we need to find g of 2 plus k squared. G of 2 plus k squared is equal to 2 plus k squared. Expand the bracket. We have 2 plus 4 plus 4k plus k squared, which is k squared plus 4k plus 6. So since they are equal, so we continue. K squared plus 2 is equal to k squared plus 4k plus 6. We have k squared at both sides. We can actually just cancel it off. So 4k is equal to 2 minus 6. 4k equal to negative 4. K is equal to negative 1. Question 4. Given the function f such that x is converted into px plus q, where p is greater than 0, and function f squared such that x is converted into 25x minus 12. We have fx equal to px plus q, and f squared x is equal to 25x minus 12. A. Find the value of p and of q. Since we are given f and f squared, we need to find our own f squared x. Then we compare the answer we obtain with the given f squared x. F of fx is equal to p fx plus q. Substitute fx again, we get p multiplied with px plus q. Then we expand the bracket. we get p square x plus pq plus q. So we compare this with this. As comparison, p square is equal to 25. P is equal to square root of 25. We get 5 and negative 5. But here, they mention that p is greater than 0. So this one, we just ignore it. So p is equal to 5. Then we compare pq plus q is equal to negative 12. We already obtained p equal to 5. 5q plus q equal to negative 12. 6q equal to negative 12. Q equal to negative 12 divided by 6, which is negative 2. Now we have a complete function f. Fx is equal to 5x minus 2. B. Find f inverse square. In order to find f inverse square, we need to find inverse function of f first. Let f inverse x equal to y, x equal to fy. Substitute y into the function f, we get 5y minus 2. Make y the subject. So we get y equal to x plus 2 over 5, which means f inverse x equal to x plus 2 over 5. We need to find f inverse into f inverse x. We substitute f inverse into the f inverse. We get f inverse of x plus 2 over 5. Substitute it again. X plus 2 over 5 plus 2 divide by 5. Simplify the fraction. We have x plus 2 times 5, 10 over 5. Multiply with 1 over 5. Then we get x plus 12 over 25. Question 5. Given function f such that x is converted into 2x and function g such that x is converted into 4x minus 3. Show that f inverse g inverse is equal to g f inverse. We have f of x is equal to 2x, and also g of x is equal to 4x minus 3. In order to show that they are equal, we need to find inverse function of f, inverse function of g, the composite function gf, and then inverse it first. Let's do it one by one. Let's find the f inverse. Let f inverse x equal to y, x equal to fy. Substitute y into the f. We get 2y, y equal to x over 2. Therefore, f inverse x is x over 2. Next, we let g inverse of x equal to z, x equal to g of z, which is 4z minus 3. 4z is equal to x plus 3. Z is equal to x plus 3 over 4. Hence, our g inverse of x is equal to x plus 3 over 4. Then we find the composite function of g of f. We substitute the fx into the function g, we get 4 fx minus 3, which is 4, 2x minus 3, 8x minus 3. Then we find the inverse of the function gf. We let gf inverse of x equal to w, x equal to gf w. Substitute w into the function gf, we get 8w minus 3. Make w our subject, we get 8w equals to x plus 3. W equal to x plus 3 over 8, which means gf inverse of x is equal to x plus 3 over 8. Now we already obtained inverse function of f, inverse function of g, and also inverse function of gf. And one more thing we need is to find the composite function of f inverse, g inverse. F inverse of g inverse x is equal to g inverse x over 2. Substitute the g inverse, x plus 3 over 4 over 2. So we get x plus 3 over 4 multiply with 1 over 2, which is x plus 3 over 8. Compare the answer that we obtained, f inverse, g inverse, we get x plus 3 over 8. Gf inverse, we also obtain x plus 3 over 8. Therefore, we can conclude that f inverse, g inverse is equal to gf inverse. So that's it for today's lesson. Hope it will help you in your study. See you again in the next video.